Hello again. So we are back, and this time we're going to be talking about adding integers and real numbers. All right, guys, let's do a little bit of review here. When we're talking about integers, we're talking about whole numbers and their opposites. So if we were starting at 0, 1, 2, 3, 4, and so forth, we would just include the opposite or the negative of those numbers. So 0 is kind of like the center, and then on either side we go out positive 1, 2, 3, negative 1, 2, 3, 4, and so forth. Real numbers. So when we're talking about real numbers, we're talking about all rational and irrational numbers. Okay, integers, fractions, decimals. And we're talking about rational numbers. We're talking about numbers that eventually terminate or that repeat. Irrational numbers don't repeat. They don't have a pattern. They don't terminate. That would be something like pi, right? The number pi. So we're including all of these numbers in this idea of adding them together and kind of how do we deal with especially those negatives that we run into. So one of the difficult parts about teaching this concept is that there are so many different methods. And the thing is, guys, is that the key would be to have you guys practice some different methods and find which one makes sense to you. Because for each person, that's going to be different, right? Some of you are going to like the rules. Some of you are going to like using a number line at first. Some of you are going to like the other methods that you're learning. So the only way for you guys to really know for sure is just practice these a lot. All right, but I'm going to walk through at least a few methods that I try to kind of teach in my classes. The first one would be the number line. Now, I would say that the number line is a really good way to start learning addition and subtraction of signed numbers. It's not realistic, though, that you can always draw a number line, especially, when you're getting into a lot higher numbers. So I think it's good at first to visualize if you're a visual learner. It's a good starting point, but I would eventually kind of, expand out to other methods that are more efficient and quicker for you. If you are using the number line, let's go ahead and look at our example here. What we would want to do is make sure that we start on that first number, okay? And then we're going to move to the right, positive, or the left, negative. So let me, and here, so the right is always our positive numbers, so the left on our number line is our negative numbers, or going in a negative manner. So we're going to start here with -3. Let's start right there. And then we are going to add 4, right? So that's going to be going to the positive by 4. So we're going to 1, 2, 3, 4, and we're sitting here at 1. Okay, so that was adding 4. And then, so how we would kind of say this next part, I know there's 2 signs here, but basically we're saying and, right? This positive would be and, go in the negative direction 9. Okay, so just switch my color here. Let's do that. Right, so we're going to go back. Let's go back 4, 5, 6, 7, 8, and 9. And we're going to end up down here at -8. So this was a subtract 9. So you can kind of go back and forth on that number line and just kind of get a visual sense of what these positive and negative numbers mean. Okay, so that would in the end be -8. All right, let's kind of move on though and use some rules here. Now, NROC teaches a rule that you can use for addition of signed numbers, and this would be for 2 numbers. Okay, this would be working with 2 numbers at a time. So we could have done that above as well. We got 3 numbers. We would have done the -3 and the 4 first. Then we would have taken that sum, and then we would have subtracted 9 from it. So you can use the rule with those 2 numbers. Even if you have more than one, you just take it a step at a time. Excuse me, if you have more than 2, you just take it a step at a time. All right, so the rule says that if we have the same signs on our numbers, that what we're supposed to do is add the absolute value of the numbers and use the common sign. So remember, this just kind of as a review here, absolute value means distance from 0. right? So if we're taking the absolute value of a number, for example, negative 21, it's asking how far away is 21 from negative 21 from 0. Well, it's 21 spaces, right? Absolute value of negative 14, that's how many spaces is negative 14 from 0? Well, that's 14 spaces. So basically, in other words, this is actually telling you to just ignore the sign and just add those numbers together. So we're basically going to ignore the sign. We're just going to say 21 plus 14 is 35. And then we use the common sign. You notice that these both have negative signs, so we're going to use that common sign. Okay, so there's an example of when the signs are the same. Now let's take a look at when the signs are different. When they're different, we're finding the difference of the absolute value of the numbers this time. And then we use the sign of the larger number. Okay, well, when we're finding the difference of the absolute values, of course, we ignore those signs. Okay, 4 is already a positive 4. The negative 18, though, we're going to treat it like it's a positive 18. And we always start with the larger number because we're finding the difference and we're not running in, we don't want to run into negatives. So you take the larger number, subtract the smaller number. It's going to give us a 14. And then we use the sign of the larger number, the larger value, not including the negative sign. So 18, gosh, sorry, I just don't know why that keeps appearing. The 18 is a larger number than the 4, so, and it has a negative sign, so we just use that negative. Now, using the rule, some students really, really like this method. I think I'm okay with it. I definitely would say if it works for you, that's great. I also, though, am always encouraging students to just think about what those numbers mean, kind of think a little bit bigger picture. Sometimes you can get locked into rules and not really see outside the box, if you know what I mean. So just, use it if it's helpful, but also just kind of think about what you're doing with these numbers and maybe where they would sit on a number line, what they would look like. Okay, so another option, which I really like, is the idea of using money, because we can all relate to our money, right, in terms of our bank account and transactions. Negative signs or negative signs on our numbers mean that we subtract or we spend. Positives means that we add or we deposit money. So let's do an example of how we might come across or kind of treat a long string of positive and negative numbers in terms of thinking about money. All right, so basically we would start here and we would say, okay, I am -2. I am overdrawn, right? Of course, you don't have to write all this out. I am overdrawn by $2. And I deposit, here's my positive, 7. I deposit 7. So I'm now sitting at $5. Now, even though it's a pain in the bum, I'm going to ask you guys to do one step at a time and write it out. Unless you're really, really comfortable with these and you've done quite a few of these, please take the time to write them out because then you're going to make a whole lot less mistakes. Okay? Okay, so we're sitting at $5 in our account and we spend 9, right? Well, we're back down to -4 in our account. Okay, and we're not very good with our bank account, so we spend more. Okay, we go to Starbucks again. -4 plus another -3. Now we're overdrawn by 7, and we've only got $4 to deposit, so unfortunately we are still overdrawn by $3. Okay, so that's kind of how we would think through those positive and negatives using the idea of money. Okay, that's just one more option. I've had some students who use scoops of dirt out of the ground. Negatives, of course, are scoops out. Positives are scoops back in. I think when I was a long time ago, when I was going to school, my teacher used the idea of a thermometer and kind of just degrees, rising up and down, and like where would that thermometer end up when it's all done. So a lot of this is visual, and I do think that visualizing your positive and negatives is good, because even though you do need to write down your steps, it's very much a number sense thing. And I really want you guys to work with it till you feel comfortable in terms of thinking about these positive and negative values and how you work with them. Here's a second example, and you will have problems like this on your worksheet that you can practice. I included this because it did have some absolute value marks, so I wanted you guys to have a little bit of practice with that. So remember that absolute value means distance from 0. When we're taking the absolute value of a number, I think up above we were looking at the absolute value of negative 21. And like I said, that means how far is negative 21 from 0? Well, it's 21 spaces. So the difference here that we see on this one is that we have two numbers in here. We don't just have this one number like the negative 21. Whenever you have that situation, remember that you have to do the math inside first. Okay, so you have to do that first until you have one number to evaluate the absolute value. So we're going to take negative 5 plus 3, so we're overdrawn $5, and we add 3 to that. So we're still at negative 2, and this is still in absolute values. All we did was do the math. Okay, now we can take the absolute value of that number, and negative 2 is 2 spaces from 0. Okay, so we're done with that absolute value, and basically then all we're doing, you guys, is bringing everything down. So we're going to add 7. Then I have a subtraction sign. I want to keep that. I have the absolute value of negative 12. Well, that's 12 spaces from 0. This is tricky though. You notice this looks like a negative 12, but I want you guys to keep in mind this is just a subtraction sign that came down here. And then we have a minus 4 at the end. Okay, so we have this string of numbers now with just addition subtraction signs. There's no more absolute value here, so we can just head from left to right. Okay, we've got 2 plus 7, which is 9. We write everything else down. Some students might have wanted to group the negative 12 and the negative 4 and call that negative 16. That's totally fine. If you decide to jump around in these numbers and group the negatives and positives, please just be careful of your signs. Don't forget to grab the sign in front. That would be the number one mistake that I see that happens sometimes. I think it's a little safer to go left to right, but that is completely up to you. 9 minus 12, right? I only have $9 in my account and I spend 12. Well, I'm overdrawn by 3 and I continue to spend. Wow, not very good with my money. All right, negative 7. We end up with negative 7. All right, moving on. So on your worksheet, and of course coming up in the remainder of the class, you guys are going to have expressions where you're asked to add and subtract and multiply and divide, actually, but they include the variables in them. And we talked a little bit about, combining like terms and what like terms are about in the last video. So if you missed that video, make sure you go back and watch that. But we have to consider what that is. We have to consider those terms and like terms when we are simplifying these expressions with variables in them. Remembering that a term is any variable, constant, variable term separated by an addition or subtraction sign. Okay, so here's an example here. We've got this long expression that has 5 terms in it, right? We have an addition, subtraction, subtraction, addition. We have 4 operations, so we have 5 terms that surround those operations. The variables, well, we've got x's, we've got y's, and we've got x squared, don't we? Those are all the types of variables that we have. Okay, now I'm including the x squared in there just because it's different than an x. Remember that the x is only to the first power, right? So that's different than an x squared. Okay, my variable terms that I have are the whole term that's sitting there. So we've got a 3x is one of the variable terms. Minus y or negative y is another term, right? Because we know there's a 1 here, so we include that whole thing, but we don't have to write that. It's just an understood 1. In fact, it's more proper to not write that 1 in there. Negative 10x squared. That whole thing is a variable term. And an x. Constants. The only constant that we see in here that is not multiplied by a variable, so it's not part of a variable term, is the 4. And the coefficients, remember that coefficients are numbers that are multiplied by the variable. They come right in front of the variable in the variable term. So we can see we have a 3, that's the coefficient of the 3x. We have a negative 1, that's the coefficient up here. Even though we don't write that 1 in there, we know that that negative 1 is sitting in front of the y. We have a negative 10 that's sitting in front of the x squared, right here. And even though we don't see it, we have a 1 that's sitting right there, right? Sitting right there in front of that x. Okay, now when we're talking about expressions, of course, one or more term with no equal sign. Later on, we're going to get into equations that are expressions that are separated with an equal sign. But right now, we just have expressions. They don't have an equal sign. They're just made up of terms. And as we talked about in the last video, we can simplify expressions by combining like terms, or we can evaluate expressions where we plug in given values to the variable and we simplify. Okay, so, and this is review. I know we did this in the last video, but we're going to just do it again because it's really important to remember and to practice these things. So, like terms, right? We've got terms that have identical or exactly the same variable parts and exponent parts. So we're just going to take a moment just to go through these and see if we can identify our like terms. I know in the last video I mentioned that I like to kind of equate them with different kinds of animals or different creatures because a lot of times they look the same. I mean, you know, we live in an area where we have beautiful birds, right? And sometimes we see them out in the forest. I live up by Galbraith, and so I hear so many birds, you know, and I look out, and if they're far away, you know, a robin might look very, very similar to a starling, might sort of look familiar to a sparrow, you know, might look very similar to a goldfinch, color-wise, obviously not. But, you know, they're all birds, but when you get close, they're very, very different from one another. And that's kind of the idea here. So we're looking once again at the variable parts. Well, this here has a x cubed on it, doesn't it? So that's not the same as an x squared. Here we have 2 x's. Here we actually have 3 x's, right? X cubed is x times x times x. Well, here we actually have an x squared, but we have a y attached also, don't we? So that's a very different creature. That's very different variable term. So we don't have that as a like term. This 2x squared, however, is a like term. The 2 on front is just the coefficient, and we don't care about that part. So that one is a like term to the x squared. And if you look across here, there's no more just x squareds. We have some x squareds that are multiplied by y squares and that sort of thing, but they're not exactly the same. So these 2 terms are the only 2 that are the same in terms of those x squareds. Okay, let's find some more. All right, so now we've got x cubes. If we cruise across this list, we can see over here we have a 2x cubed. So those are like terms. All right, here we have an x squared y. We happen to have a negative x squared y, but the negative sign doesn't matter, the negative 1 in front. Let's look for more x squared y's. X squared y's, here we go. And the other ones are not. You notice here, interesting, we've got 2 y's and 1 x, whereas over there we have 2 x's and 1 y. So we cannot use this one. In fact, if I go through, it makes a little more sense here. There's a 1 on the y's, 2 on the x's. Here we have a 1 exponent on the x and 2 on the y's, right? So they're not the same. All right, and if we cruise through here, this is different than this. This is just an x, is different than this. These are all very different from each other, right? So there's no like terms with those particular terms. All right, guys, so when we're combining our like terms, so once we find them and we combine them, remember that we add or subtract the coefficient or the number part, and we keep the variable parts exactly the same. So in this example here, we've got 3x plus 4x. All we're really doing is saying I'm going to take the 3 plus the 4, and I'm going to call it 7x's. You notice my duck stays a duck. I'm gathering them all together, but they're still ducks. I have 7. I'm just trying to figure out how many of them I have. Here I've got 13 xy's, right? And I'm subtracting 9 xy's, which leaves me 4 xy's. Okay, here I got kind of a lot going on, so I want to see if I can isolate my like terms first. So here I have x squared y's. Do I have any more x squared y's? Yes, I do. I've got 3 of them here. And the xy in the middle is a different type of animal, right? Different type of variable term. So if I want to, I can pull it out front. I can say I have -1 plus 3 of them, of these, let's call them ducks, right? So I've got 2 of those, and you can see right up here, I've got 2 of them. And then the xy is something different, so it just stays out at the end by itself. And this is actually considered completely simplified because, once again, I cannot combine those terms that are not the same. Now this is actually really important. I want you guys to note that we do not combine like terms when we're multiplying or dividing. We only combine like terms with addition or subtraction. You notice when we were looking at those expressions, we had lots of stuff that was multiplied together, but they were almost held together like glue, right? And they were not separate terms. Let me go back. For example, let me just take this example here. I'm going to go back. Right here, this 13 is multiplied by the x, it's multiplied by the y, right? This 9 is multiplied by the x, multiplied by the y. But you notice it's still considered one term, and this is still considered one term. But we have a subtraction sign in the middle, which separates those terms, and that's why we have 2 terms there, right? And you can see all the way across, you know, this addition sign separates those 2 terms that happen to be multiplied together, right? We could have also had division. We could actually have something like x over 2 plus 7. Okay, those are 2 terms, right? We have that the addition sign that's separating them, but we also have a division going on right here. It didn't separate the x from the 2. It's still considered one term. So multiplication and division, we do different things with that. We don't consider that combining like terms. What we do is we use exponent rules, and we're going to talk a lot more about that in Unit 11 coming up. So here's the difference, right? 3x plus 4x is 7x, gathering all the x's together. 3x times 7x, we use something called the product rule. And like I said, we're going to get into it a lot more. In the product rule, though, what we do when we have the same bases, these x's are called bases. When we have the same bases, we add the exponents. And so you can see, not only did we multiply the 3 times the 4 to get the 12, we added those exponents, and now we have x squared. With division, we use something called the quotient rule. Okay, quotient rule. So instead of up here when we would have subtracted 14x squared minus 7x squared, well, that would give us 7x squared. It looks like that one's actually not finished here. That would be 7x squared, right? We're just figuring out how many x squareds we have. Instead, we use the quotient rule, and what the quotient rule tells us that, first of all, we would kind of consider this as a fraction. 14 divided by 7 is going to give us 2. And these an x squared divided by an x squared, what we do is we subtract those exponents. Okay? So x squared to the 2 or x to the 2 minus 2 is x to the 0, and that's actually a 1. Okay, that's a little bit hard to explain that to you guys right now, but the best way to look at that, if we go back, anything divided by itself is just 1, right? So all of this explanation here using quotient rule tells us that that's just 1. But we know 2 divided by 2 is 1. X divided by x is 1. X squared divided by x squared is 1. So in the end, this is just a 2. So more on that in Unit 11. Okay, my whole point in bringing this up now is I want you guys to understand that combining like terms is just for addition and subtraction. All right, and let's end with just a few problems that we can use to practice. Some of these are from your worksheet. All right, so here we have a negative 10x squared plus a negative 5x squared. Okay, well, can we combine like terms? That's always our question, right? Can we combine like terms? Well, we've got x squareds here, and we have x squareds here, so we surely can. So remember that our first step is to add or subtract. Later on, we'll be subtracting the coefficients. So plus a negative 5, it's the same as minus 5. I'll leave it as plus a negative for now since we haven't really talked about that yet. But they're all x squareds. We don't change. We keep the variable the same, right? So in the end, this is going to become negative 10. I'm overdrawn $10 and I spend 5 more. Negative 15, negative 15x squared. All right, this second example here, I've got all x squareds, right? And they're all being added together. Well, if it's comfortable for you, if it's more comfortable, go ahead and add your coefficients. We know there is an understood 1 in front of all of those x squareds. So in the end, we add all those coefficients together, but we keep the variable part the same. All right, lastly, I threw in several different variables. So we have to consider the like terms first. Okay, so I've got some x's here. Let's see if we can find any more x terms. Here we go. We've got 4 x's here, got another x here, and that's it. Okay, looks like I've got a couple y terms. So I've got a negative 3y plus a 5y. And then I have a z term, but it's kind of just sitting on its own, so I don't need to worry about combining that. Okay, so let's go ahead and add our negative 1. This is a negative sign, so it's a negative 1 over here. It's going to be a positive 1, right? So I can bring these down below if I want. Negative 1 plus 4 plus 1 x's. Well, plus 1 minus 1, that's just 0, so I've got 4 x's, don't I? I also have negative 3 plus 5 y's. That's going to give me a positive 2 y's. Okay, now this can be a little confusing, but it's a plus 2, isn't it? It's a positive 2, so you're going to bring that plus sign down and just set it right here. Because it's a positive, if you're simplifying in this manner where you're taking the time to collect them in parentheses and all that, which is kind of a side note, you have to keep in mind that if your final answer is negative, you're going to use a subtraction sign down here. If it's a positive, you're going to use an addition sign down here. Okay? And we haven't finished up because we have to get that z in there. Now we're done because x's, y's, and z's are all different terms. They're different animals, so we just leave it like that. Even though it kind of doesn't feel done, it is simplified. All right, guys, we will talk about subtraction of integers and real numbers in our next video. Talk to you soon.